Hi there, this is a follow-up to my first Horizon video, and in this video I'm going to be discussing these instruments which you'll find in the cockpit of almost every aircraft in the world. It's the Artificial Horizon. I'm also going to be talking about this aircraft. This is the iconic Concorde. Unfortunately they don't fly anymore. The last one flew in 2003. Kind of regret not having been a passenger on one of these planes. The reason I've chosen to talk about a Concorde is because of the particularly high altitude that they fly at. They fly up to 11 miles high, and that really presses the point that I'm trying to make in this video with regard to Artificial Horizons, these instruments. So I'm going to show you a couple of brief videos on how these things work, so stay tuned.
The attitude indicator, AI, also known as gyro horizon or the artificial horizon, or attitude director indicator, ADI, is an instrument used in an aircraft to inform the pilot of the orientation of the aircraft relative to the Earth. It indicates pitch, fore and aft tilt, and bank or roll side-to-side tilt, and is a primary instrument for the flight in instrument meteorological conditions. Attitude indicators also have significant application under Visual Flight Rules, VFR. I like to think of it this way. The center white line separating the brown or ground from the blue sky is our horizon. The yellow line running across it, think of this as the wings on the aircraft. Now, bearing in mind, if you're looking at the cockpit in the aircraft, you're keeping it in line with the horizon. Now, on this instrument, the wings, or the yellow line running across the horizon, should be in line. If the symbolic aircraft is above the horizon line, the blue background, the aircraft is nose up. If the symbolic aircraft is below the horizon line, the brown background, the aircraft is nose down. Because it is the horizon that moves up and down and turns, while the symbolic aircraft is fixed relative to the rest of the panel, trainees get confused. A standard corrective given by flight instructors is fly the little airplane and not the horizon.
Okay, so I was reading through some of my old textbooks when I was learning to fly. A couple of them here. But this one in particular, The Helicopter Pilot's Manual, Power Plants, Instruments and Hydraulics by Norman Bailey. If we go to the instrument section, we can see this page here is the Artificial Horizon, and it explains how it works. And the important bits I've underlined there. So let's get a snapshot of that. So it reads, because the horizon bar is connected to the gyro, it remains parallel to the natural horizon. Further down, the artificial horizon gives an immediate indication of even the smallest changes in attitude and has no lead or lag. So what that's saying is that it is an extremely sensitive instrument and it reacts instantaneously to any attitude change of the aircraft. When the nose is raised above level attitude, the pictorial display shows the same attitude change in miniature. So this is it is mimicking the movements of the aircraft absolutely precisely, and I'm sure any pilot watching will concur that it is an extremely sensitive instrument and does react instantaneously. So let's have a look at one of them opened up and being demonstrated in real time. So this is what the rear of the Artificial Horizon looks like. This bit is hidden away behind the instrument panel in the aircraft. So this is the front face of it. This here is the gyroscope, it's got a flywheel in there that's rotated at very, very high speed, either electric or air driven, and this is sort of gimbaled inside this mechanism, so it is allowed to rotate freely and independently from the rest of the instrument. So just have a look at it in action. You can see it there, look. It remains parallel to the ground no matter which way you turn it, and it reacts instantaneously, just like the book said. See the quick sudden movement there? And it stayed perfectly parallel to the ground. Okay, let's go back to AutoCAD. Now in my last video, which I suggest you go back and watch if you haven't already, I explained how accurate AutoCAD is. It's used by engineers in all kinds of industries throughout the world, and it is accurate to, I don't know, hundreds, thousandths of a millimetre. And it takes away all the hard work. I don't need to do any maths for this. I can simply draw lines, draw them back onto circles at tangent points, and it will tell me what the angle I've drawn it at is, and tell me lengths of everything. So let's have a look at the Boeing 747 from the previous video, just to recap. It's 6 miles in altitude. If I click this line here, it tells me it's 6 miles high at an angle of 90 degrees from the horizontal. Let me just select the Earth again. I'll just zoom out so you can see it. This is the exact size of the Earth as generally accepted. So if I look here, it tells me, look, it's a circle and it's blue. It tells me the radius is 3959 miles, and it tells me the circumference as well. The plane's obviously been drawn at a much enlarged scale so that you can see it easier. But I've drawn a line from a passenger on the plane from the window. Well, it's actually to the centre of the plane, but it nearly passes through the window there, so it's accurate enough. Down to the tangent point on the globe, which is here. So this is the horizon point from the perspective of a passenger on the 747. And from the previous video, we showed that it was 3.15 degrees down from the horizontal. Okay, let me just get rid of that. And get rid of the 747. Okay, let's look at the Concorde. Now the Concordes can fly up to 11 miles in altitude. So this line here, if I select it, look at the properties, length 11 at an angle of 90 degrees. Now, do you remember the old gyroscopes that you used to have as a kid? And you wrap a piece of string around it and pull the string and it spins up the flywheel. So let's use that as an analogy here, because that's exactly what the artificial horizon is, the instrument that we've just looked at. So imagine the toy that you had as a kid, the gyroscope. This is the axis, and this here, the horizontal, is the flywheel. The artificial horizon in the aircraft is obviously a lot more accurate than them toy gyros. They remain precisely straight and level with the parallel to the ground. But if you were to take the analogy, this, no matter how high you are, with the gyroscope, as long as you're staying above that same point on the Earth, it will remain the same. This is globe Earth we're talking here. It will remain the same. the gyroscope will be, the flywheel will be going horizontal, and the axis of rotation is vertical, no matter where you are up this line here. Okay? That would mean that the flywheel, the horizontal flywheel spinning, is in this plane here, the horizontal. So what is it that the artificial horizon instrument is reading? Have a think about it. It's reading this. It's reading parallel to the ground at the particular point you are above the Earth. Again, assuming it's a globe. Let me just freeze that for a second. Concord flat. And we'll thaw Concord angle. Okay. I've drawn a line from the 11-mile high point, which is from the pilot's window in the Concorde, and I've drawn that at a tangent to the Earth at the horizon point, just here. So that line there is length 295.3 miles, and if we take a line out from the horizontal here and draw a line down to the horizon point, you can see that it's almost 22 miles. So it's again almost double the altitude of the aircraft here, which is 11 miles. And just to clarify that it is the tangential point just here, I've again drawn a line from the tangent point to the centre of the Earth here, which is the precise centre, and it forms a 90-degree angle. So we know that that's the tangent point. Okay. If I use AutoCAD's dimension tool, I can interrogate it and find out what the angle is between here and here, just by clicking the two lines, which I did here. And it turns out it's 4.27 degrees. Now remember earlier, when I was reading that section in my textbook about the artificial horizon being extremely sensitive. Now, 4.27 degrees is a lot when you're talking about the artificial horizon, and as you can see, the plane, the aircraft is tilted. The passengers on this plane would most definitely be aware that the plane was in a nose down position, without a doubt. And for the avoidance of doubt, let's check out some other official sources of definitions of the artificial horizon. So this is the Free Dictionary. An instrument that indicates the pitching and banking of an aircraft by displaying the movement of a representation of the aircraft in relation to a line representing the horizon. Let's go to this site, which is Your Dictionary. Artificial horizon, a gyroscopic instrument on an aircraft for indicating the true horizon, and I've highlighted that, true horizon, and the position of the craft with reference to it. If I go back to my textbook that I read from earlier, it says, because the horizon bar is connected to the gyro, it remains parallel to the natural horizon. So they're pretty unanimous on it. There's no mixing of words at all. They're saying that the artificial horizon aligns with the true horizon or the natural horizon, which is here. That's what they're saying. But they can't both be correct, can they? It's either the aircraft is tilted down and facing the globe's horizon, or the aircraft is level and the gyroscope, the child's gyroscope analogy works, whereby you've got a 90-degree angle formed here. Based on what I felt when I'm on aeroplanes and when I'm flying in helicopters, that has to go. That is what we feel, that is what we experience. Meaning that the artificial horizon does not point downwards to a horizon point here. It can only point horizontally. And there is only one model where everything we see and everything we observe fits what I've just explained here, and that is the flat Earth model. And one last thing to get your head around is this line here is not the only horizon from the perspective of the pilot. Provided he turns the aircraft round, he can view horizons in all different directions, 360 degrees of horizons, if you like, all the way around him. So what would necessarily make his artificial horizon point specifically in this direction, when there's another horizon in this direction? It has nothing to do with movement or forward airspeed. Let's go back to the analogy of a helicopter, and yes, I know helicopters don't fly this high, but let's go to the analogy of a helicopter hovering at this height. He can remain there, straight and level, and we know what the instruments are going to show. But this doesn't necessarily mean that once he transitions from the hover into forward flight, that the artificial horizon is going to suddenly shift and drop to point at the true horizon in the particular direction that he is travelling at. It doesn't work like that. Although all indications and all external sources seem to suggest it should. I hope you've enjoyed this video. It's been quite a heady subject to get my head around. It's led me onto all kinds of other thought tangents, and I plan to make some more videos showing these. So if you like it, please comment, subscribe, more to come.